Hello everyone, hope you all are doing well. In this video, we'll discuss the second problem of Leetcode Weekly Contest 294. It's a medium level problem. The problem name is maximum bags with full capacity of rocks. So the problem statement says that we are given n bags numbered from 0 to n minus 1, and we are given two arrays. One is known as capacity and the other known as rocks. So what these array denotes is that the ith bag can hold a maximum of capacity of I rocks, and currently the number of rocks present in the ith bag is rocks of I. So that means for each index I, capacity of I denotes the maximum capacity of that bag, and rocks of I denote the number of rocks currently present in that particular bag. We are also given an integer additional rocks. This denotes the number of additional rocks that we can place in any of the bags. So what we need to do is that we need to return the maximum number of bags that could have full capacity after placing the additional rocks in some bags. So let's try to understand this with the help of an example. So this is the capacity array. We have four bags with a capacity of 2, 3, 4, and 5, and the current state of those bags are 1, 2, 4, and 4. That means the first bag has one rock, the second has two, the third and fourth have four rock each, and we have additional two rocks. So we need to tell that how many bags can have full capacity. uh, we can fill these stones in the way that the bags are full. So if we place one rock in bag 0 and one rock in bag 1, so the number of rocks in each bag will be 2, 3, 4, and 4. Because the capacity of the first bag is 2 and the number of rocks is 1, so we can still place one rock so that it becomes full. So we place one in the first bag and it becomes full. If we talk about the second bag, so again the capacity is 3, but we have two rocks, so we can place one extra rock in this, so this also becomes full. If I talk about the third one, so the capacity of third this was 4, and we already have four rocks in this. So the total number of bags that can have full capacity is 3, because we have only two additional rocks and we have already placed one rock each in the first and the second bag. So the answer comes out to be 3. If we look into the second example, so the capacity is 10 to 2, and the number of rocks right now present in the bags is 220, and we have additional 100 rocks. So we have sufficient number of rocks, because to make the first bag full we need 8 extra rocks, because we already have 2. To complete the second bag is already complete. If I talk about the third bag, so we need just 2 rocks, so totally we need just 10 rocks. So we have sufficient amount of rocks, so all the bags will be full. uh, so yeah, the answer will be 3 in this case. The constraints say that obviously the capacity length and the rocks length will be same, because they denote the same number of bags, which can be up to 5 into 10 raised to power 4, and the capacity of I can go up to 10 raised to the power 9. The number of rocks can be from 0 to just equal to the capacity of I, and the number of additional rocks that we can have is 10 raised to the power 9. So yeah, these are the constraints. Let's try to understand how we can solve it. Again, I would say an implementation based problem. All we need to do is that keep track of the bag which needs minimum rocks to fill. So for example, if I talk about, so suppose this is the array, these are the bags that we have, suppose, and yeah. So what we do is that we have a capacity array and we have a rocks array. So for each bag, what we do is, so this is a greedy level problem. What we can do is that we will see that which are the bags which need minimum number of rocks to get filled, right? So which are the bags which need minimum number of rocks? So how we can calculate the minimum number of rocks required for each bag? What we do is that we subtract rocks of I from capacity of I, because capacity of I is the maximum number of rocks a bag can have, and rocks of I is the current number of rocks that we have in the bag. So for each I, what we do is that we do capacity of I minus equals to rocks of I, right?
So now this is the new capacity, denoting that I need this number of extra rocks to get filled. Now all we do is that, since we have only some rocks, what we do is that we sort this array capacity of I, we sort this array. So that means we will have the bags in the order that bag requiring minimum number of rocks to get filled will be at the beginning, and will go in increasing order of the capacity, the new capacity. So then finally what we need to do is we need to traverse the array, and we need to see whether we can fill the, for each index I, whether this bag can be filled or not by the given number of rocks that we have. And all we need to do is that we need to return the final answer. Let's look into the code. uh, this is the main concept to solve this problem. So if I talk about the solution, so yeah, we compute the length of the number of bags that we have, and as told, we compute the new capacity, where capacity of I is equals to capacity of I minus rocks of I. That means now capacity array will have the number of rocks needed to fill that particular bag. Then we sort this array and we start traversing it. All we need to do is that we check whether the number of rocks that we have right now is that greater than or equal to capacity of I. If that is equal, if this condition satisfies, that means this bag can be filled. So we increment the answer and we decrement the number of rocks that we have now. So additional rocks minus equals to capacity of I. We run this loop and finally we return the answer. Now we can add an extra optimization in this one, that as soon as the additional rocks basically becomes 0, and if the capacity of I is not equal to 0, then just break the loop. But again, since the constraints were not pretty high, I just ran the loop. It was just 5 into 10 raised to the power 4. And yeah, this is the solution. And the time complexity for this one will be uh, for sorting. So we are doing the traversal a couple of times, so that will be big O of n, and for sorting it will be big O of n log n. So the overall time complexity comes out to be big O of n log n. Yeah, if you learn something new, that give do support this video by giving up the thumbs up, and see you in the next video. Bye bye.